Here is a question from JEST 2014. We are given an operator A. We are asked to find the width delta A in LM state. LM state is the simultaneous eigenstate of L square and LZ operators. So the width or uncertainty or standard deviation of an operator A, delta A, is defined as under root expectation value of A square minus A expectation value square. So we need two things to solve this question. One is the expectation value of A square and the other is expectation value of A. Then we have to put in this equation and we will be able to find the width delta A. We are given A is equal to n cap dot L. So this is equal to sin theta cos phi Lx plus sin theta sin phi Ly plus cos theta Lz. Now expectation value of A is equal to sin theta cos phi expectation value of Lx plus sin theta sin phi expectation value of Ly plus cos theta expectation value of Lz. I want you to keep in mind that when we write expectation value of A, then that is with respect to Lm. So it is actually like this: Lm A Lm. And when I write Lx expectation value, this is Lm Lx Lm. But for convenience, I'm only writing this thing. But you have to keep in mind that this is with respect to state Lm, and Lm is the simultaneous eigenstate of L square and Lz operators. So in this state Lm, the expectation value of Lx is equal to expectation value of Ly is equal to 0. Also expectation value of Lz is equal to m h bar. These things you can prove. For proving Lx expectation value equal to 0 in the Lm state, you can use Lx equal to 1 by 2 L plus L minus. So if you put these things, then you will get that the expectation value of A, this is equal to sin theta, first two terms will become 0, cos theta m h bar. Therefore expectation value of A square is equal to m square h bar square cos square theta. I want you to keep this in mind. We will use it later. Now let's calculate the expectation value of A square. A square is equal to sin square theta cos square phi Lx square plus sin square theta sin square phi Ly square plus cos square theta Lz square plus cross terms. Now if you calculate the expectation value of A square, this will be equal to sin square theta cos square phi expectation value of Lx square plus sin square theta sin square phi expectation value of Ly square plus cos square theta expectation value of Lz square plus expectation value of cross terms. Now if you calculate Lx square expectation value, this will be equal to Ly square expectation value, which is equal to h cut square upon 2 L into L plus 1 minus m square. Lz square expectation value, this will be equal to m square h bar square, and expectation value of cross terms will be equal to Lz Lx expectation value, Ly Lz expectation value, Lx Ly expectation value, all of these terms will be equal to 0. Therefore the cross terms does not contribute to the expectation value of a square. This will be 0. And if we substitute Lz square expectation value is m square h bar square, Lx square expectation value is equal to h cut square by 2 into L plus 1 minus m square. All of these things, if you put in this equation right here, you will get a square expectation value is equal to a square expectation value is equal to sin square theta h cut square upon 2 L into L plus 1 minus m square plus m square h cut square cos square theta. Therefore width delta A is equal to under root of a square expectation value minus a expectation value the whole square. A expectation value the whole square is this thing, m square h bar square cos square theta. So if you subtract expectation value of a the whole square from expectation value of a square, then you will get under root sin square theta h cut square by 2 L into L plus 1 minus m square. So this is equal to root of L into L plus 1 minus m square by 2 h cut sin theta. So this is the width delta A. Correct answer will be option B. While solving this problem, we used some ready-made results like expectation value of Lx square, Ly square, expectation value of Lx, Ly, etc. Of course, you can derive this during exam, but it will cost you some time. So if you can retain some of the things in your memory, it will be definitely an advantage for you. That's all. Thank you.